So let me hand over the session to you. Over to you, please.
Thank you, NK, and I wish to thank 3AI for giving me this opportunity to present on such an important topic of anomaly detection. So while we can probably see a lot of ambitions across the world for smart cities, we're looking for fintech revolution, digital transformation, so on and so forth. Anomaly detection, anomaly spotting forms a very integral part of the whole scheme of things. So while we won't have a robust framework, a lot of ambitions in terms of making sure we're having a large footprint in terms of AI and automation. Anomaly detection, if it's not being attended to a spot, it can relate to fraud, it relate to various type of leakage of revenues, and so on, so on, and so forth. So what I would like to do in this 50-minute presentation is that I want to take you through in terms of why anomaly detection is going to be important in this scheme of things and how it is coming in handy for not only having a robust transformation of smart cities, industrial automation, all of these things, making sure that the foundational block is strong enough so that there isn't very type of leakages happening into this. What are the various type of use cases? How are industries, how are the personas trying to use the anomaly detection? What are the various use cases? What is anomaly detection? What are the different types of anomaly detection? And is anomaly detection only a machine learning algorithm? Is it a solution approach to it? What are the various aspects, which is, what are the life cycle of anomaly detection? In this day and age of open source AI algorithms, I will be taking you through various type of libraries, open source libraries and Python libraries, which are compatible with Azure, AWS. What are the libraries and how we can utilize them? And there will be some live demonstration in terms of the TensorFlow, in where it's enabling an open source autoencoders based anomaly detection, how it can be used in real life scenarios, and the most important, in terms of what are the anomalies which can be detected in AI algorithms. So we can see a lot of issues in terms of society, in terms of AI algorithms taking business decisions, and how we can actually mitigate these issues in those AI algorithms, which is going to have legal ramifications, and the whole idea of the whole area of digital transformation coming to life. And the last but not the least, with the COVID pandemic hitting us, the whole cloud and the transformation, digital transformation has gone up so much. So how are the modern data architecture, the Azure data factories, the AWS platforms, and how it can be used to enable anomaly detection is going to be the large area of discussion during our presentation. So what is an anomaly? It is an unusual pattern. It is a irregular behavior of either a univariate, which means it could be a temperature, it could be a pressure, it could be a KPI, it could be a univariate measure, or it could be a bivariate in terms of two particular KPIs not trying to behave in a certain manner, or maybe a univariate and bivariate can be clearly visible by human eye. But when those variables become multivariate, that is where the kind of machine learning techniques comes into play. It is an inconsistent factor to it. It is something which is trying to go away from the norm or deviate from the norm. So what are the methods? Say for example a Volkswagen case where there is an emission scandal coming in. The anomalies were existing. The BP well, in terms of showing the flow issues, in terms which created such a big havoc. There were anomalies which is getting detected, but if we had anomaly detection system, it could have saved a country, it could have saved an economy. If you probably look at the Wells Fargo case, where there were issues happening in terms of account issues and all of these. If you look at the case, the major frauds which are happening, anomalies show up in the system. It's just the ability to spot them and take corrective action can mean a lot to the business. So what are the different use cases which are there? Probably if you look at the finance case, there is a constant threat of personas to fraud the system in terms of finance, in terms of making fraudulent payments, the travel expenses, spend analysis, the whole element of KPI management in terms of frauding the financial ratios. So can I spot an anomaly there? The big element in terms of the anti-money laundering, the banking, the whole element of the cyber intrusion. There are so many types of cyber intrusions, so many aspects of the fraud in terms of the telecommunication, the network intrusion, the spamming of the internet system, the spamming of the social media system. What you can understand from the whole element of the scenario is that the y-axis is very different. every case, it's very difficult to model this whole an anomaly detection in a kind of an x to y mapping variable. That is where the unsupervised method comes into very big advantage. What typically happens is that supervised machine learning is the king, definitely the king. There's so many use cases are there. With unsupervised machine learning methods, wherein the various y-axis is going to be very different. Say, for example, it's going to be a temperature pressure in terms of an automotive. It could be money payable. It could be payments. It could be internet traffic. So the different variables are there. That's where the unsupervised machine learning comes into play, where the dimension space where the machine learning models can identify what is anomalous given a certain pattern, rather than be trying to train a certain model. So unsupervised machine learning is useful when a training is not available, when the number of variables are multivariate, and it's going to be critical that we need to understand the anomalies which is trying to happen. So what we do in this case is that we understood the fact that the number of signatures for a data could be multivariate. It could be frequency, could be multivariate, high level of frequency. So the unsupervised machine learning method comes into a lot of advantage in terms of it gives you a portfolio of different type of methods. So signatures can be identified. It could be a univariate, bivariate, multivariate. When it goes to a multivariate space, that is where the different type of anomaly methods are there. Say, for example, a clustering method could be coming into play. There could be something regarding the time series method could be there. Something regarding in terms of the difference in terms of angular differences could be there. So what is critical is that if with the portfolio of these machine learning algorithms, use them and try to see what are the methods which are showing a different type of anomalies. So it's very important to understand the holistic method. Use of a single anomaly detection method might not be the right thing to do. We're using a multiple different type of anomaly detection method and try to determine giving a holistic view into the whole scheme of things could be a very important requirement. Going forward, leaving the anomaly detection models to choose the anomaly and take a business decision could be not the right thing to do. Where the human in the loop is going to be critical, where we'll be taking through a certain live use case in terms of it's important to identify, to understand that the signatures of the data could be multivariate, to understand that it could be a combination of different variables. Different methods of an unsupervised machine learning methods are going to give different type of results. It's important to identify what anomaly detection methods going to understand what type of results, and more importantly, trying to have a holistic view of things, and more critically, in terms of having a human in the loop. Is that anomaly making sense? Is that explainable? Is it having a bias? Is it a fair adoption of the whole anomaly detection? Is it really an anomaly or a business critical decision is going to be critical? So it's not a one solution fit all. It's going to be a common interface, common interference in terms of whether the anomaly detection making sense or otherwise it's going to be critical. Here we want to see a lot of algorithms available. The open source world, if you can probably see, one of the popular used libraries is PYOD. So Python Outlier Detection library is a very popular open source library, which has got a whole host of open source models, algorithms in place. I would like to urge the audience to go through this particular set of resources where we can go and see there are publications, books, journals, outlier detection, the outlier methods, the graph-based algorithms, the time series-based methods. It's important to decide what sort of model algorithm. If it's a high dimensional space, what sort of anomaly detection methods should be there. If it's a low dimensional space, it's going to be a image, it's going to be a voice. So every type of a data set requires a different type of an anomaly detection. And what are graph outline methods in terms of usage of natural language processing? There are outline methods. You have LDAs, you have topic to vec models, which is trying to tell you what is an outlier in terms of the certain usage of words and all of those aspects as we speak. So then if you see, what I would also want to cover in this session is that there are different types of models. I have a tree-based model, which is going to be a forest isolation forest. So where I use a tree-based model is going to be very important for me to isolate a certain element, where it's going to be when there is a dependability in the data, you use a tree-based method. A cluster-based method is used when I have reasonably aware that it's based on a certain type of clusters. I know there are the correlation within the cluster is very high, the correlation between the cluster is very low, and I want to understand within the cluster what is happening, where I know the personas within the data set, which I know in a certain type of ways. If there is going to be a time series base is a very important element. There are two types of anomalies in time series. One is a temporary spike, which I want to identify in terms of time, then a persistent type of an anomaly. So, what is a persistent type of an anomaly? It could be a blood sugar analysis, could be a virtual machine analysis, or it could be a temperature pressure many. One is a spike, one is a persistent method, and it's slowly creeping towards an anomaly. So, if you look at an Azure data stream analysis, where I'll be taking you through in a while, is that also tells you about it looks like a certain element, even though not an anomaly right now, it is going to be an anomaly if left unattended over a period of time. That is where the risk control, risk mitigation comes into place. Then you talk about the in terms of network heuristics in terms of network. So what I would like to do, I would like to take you through the popular machine learning algorithms which are being used, which has been won awards, which has been used in various type of databases. The first and foremost, I want to take you through the one class SVM. So if you look at an Azure database, Azure cloud-based services, it is offering two services as a popular anomaly detection. One is one class SVM, the second is PCA. One class SVM is trying to delineate a hyperplane between the two variables so that it tries to differentiate between the two class two variables. So more and more I try to differentiate between two class variables, I'll be able to see how much separated they are. So this is a very popular. KNN is very popular. The nearest neighbor, you want to see how many nearest neighbors are there. Depends on the nearest neighbor. I want to see what are my variables which are not confining to my particular layer of a cluster. If you can probably say the most popular anomaly detection technique, unsupervised method, is the forest. If you look at Amazon Web Services, they call it random cut forest, isolation forest. What it tries to do basically is to cut and make trees as much as possible to isolate a certain variable. So there are basically an unsupervised method is a ranking problem. A ranking problem essentially means that I want to rank a certain variable. A high score could mean anomaly, or a low score can be an anomaly. An isolation forest is a very rare scenario in which a low score of an isolation forest is tagged as an anomaly, which means that I'm able to easily isolate an element which is not actually dependent on other aspects. The third aspect is a local outlier factor. A local outlier factor is that basically I have various clusters in place. Within my cluster, my confidence interval is a little more than what is there in the other scheme of things. So it's very critical to understand what is the type of data I'm utilizing, what type of anomaly, what is my confidence interval, what is my confidence interval in terms of sensitivity. Do I have a 95%, 98% confidence? How much I can let go a certain particular type of variable is going to be important. So where I change my confidence interval, I may want to determine how much of anomalies I want to evaluate and track and all of these things. Then the auto encoders, which I have a particular slide, auto encoders trying to compress the bottleneck and recreate the whole model again. So that is where you have I'll show you some live examples as to how it is operating in terms of unsupervised machine learning data, and it's creating a lot of aspects in terms of learning is concerned. As I said before, unsupervised machine learning, the flagship algorithm is the forest. Isolation forest is heavily used in anti-money laundering. It is used in a lot of other concepts of the financial information is concerned, where if you can probably see this information, for me to isolate any information available here, it requires a lot more cuts, which means that the tree is much more deeper for me to finally isolate a certain thing. If I can isolate, if this the basis on which isolating this particular variable is much more easier when compared to the others. So what it tries to do is that you don't need to have training label data sets. It's trying to delineate a certain type of an information which is showing you a kind of an anomaly, which is going to be very critical. It's, as I said, it's heavily used in anti money laundering. It's used in the manufacturing, the modeling in terms of predictive analytics. So this is a 2D graph. I can increase it to 3D, 4D, and ND as we speak along. Going forward, autoencoders. So autoencoders, what it tries to do is basically I have a certain input, say for image, I have a certain data set. I condense the data set. I make it a bit of a bottleneck, which will make the most important characteristics of the particular model being understood, and I recreate the whole model in terms of what I have with respect to bottleneck. What is it I'm trying to do is that I'm the autoencoders using neural network is trying to learn the most latent representation, the most critical aspect of an input which is required for me for the particular data set. It could be a certain image, it could be a certain characteristics. Then I recreate the same input from that latent representation, which is trying to tell me whether it is there. When there's a deviation between the recreated output with my input, that is where the TensorFlow model is going to flag that particular anomaly. So I would like to take you through a live demonstration of this particular case. Let me do that. Yeah. Sorry, 1 minute. So this is the TensorFlow open source autoencoders file list, where this is a use case wherein we are learning from an ECG data set. The ECG data set has got certain type of particular scoring, a particular type of image restriction. What it's trying to do is basically to condense the latent representation and learning from these particular ECG data set, and then trying to recreate in terms of the variation in terms of the error is concerned. If you can probably show you a live demonstration here. So this is where an ECG data set is trying to recreate. When I'm going to give a new ECG data set, it's going to compare against the input and recreate the output, which is trying to say that it is quite a normal in a certain way. Then there are certain cases in which the ECG data sets are abnormal. So the whole beauty of this particular data set is that without a training, without a labeling of a certain data set, I can give an input data set, it crunch it, it'll try to recreate an output and try to see is there an anomaly in the whole scheme of things or not. So this is what I'm trying to say. Within a certain threshold is there, it's sort of minimum mean squared error in a certain way, it is certain abnormal. Say for example, I want to draw a certain anomaly, certain ECG myself, and see whether what it's trying to do in terms of trying to predict it. So when it's giving an abnormal data or an input, it is clearly trying to say it is actually not normal, where the level of threshold has increased significantly. So through these data sets, we can identify what is normal and what is not. The same use cases can be used for a banking information. Say, for example, you're going to have a list of cases of fraudulent credit card transaction could be the same. I want to recreate the whole thing. I could have images. The auto encoders methodology is heavily useful when it comes to a lot of dimensions in the data set. It could be image, it could be internet traffic is very heavily useful. In terms of intrusion detection, the intrusion detectors are 100 ways of trying to do intrusion, where we try to create the rules are not going to be much useful. So that is where what happens is that the auto encoders method of crunching the data set and recreating data set is going to be heavily useful in trying to identify anomalies, and these are open source databases which can be really useful to identify anomalies. So so a typical anomaly life cycle is that I decide what sort of data I have in hand. So depending on the type of data, I need to choose my model. Depending the type of outlook I need to achieve a model, I need to be able to visually see a certain representation. If I have 1D, 2D, 3D, I can see how why it is showing anomaly. Beyond a three-dimensional space, it's very difficult for us to see why it is showing anomaly. So it's important to choose the right type of anomaly detection method, and it depends on the data set, which I showed you in terms of the PYOD database, very clear representation. Then in terms of anomaly detection, it is useful to use multiple type of data sets, multiple type of anomaly detection methods, so that you can use an ensemble technique and say what are the different types of anomaly detection which is scoring a certain data variable as anomalous or otherwise. And the third most important thing is that is a validation of anomaly. it's not a good practice to use the anomaly detection to take business decision where you have a human in the loop which will identify, which will also validate, revalidate. While you have an unsupervised machine learning method, there's a linkage between an unsupervised and supervised machine learning method. While we start identifying the patterns of anomaly, it's useful to have a model for classification or model for regression as we go along. So a combination of all of these things are going to be important. It's not important, it's not useful to deploy a certain model and use it and see whether it's showing a model drift. A certain model has been using for over a period of time. Are we sure that the data type and the variable is not changing? Is going to be important. Is the model explainable? Is also going to be important. Is the model showing a fair amount of? Is it fair? Say for example, I'm going to have an image classification model where I have the large volumes of databases is basically one racial type of people, or in terms of I'm going to have a credit card or a financial fraud or KPI. If it is not represented in a certain manner, the anomalies are going to be detected, not going to be fair in nature. So I want to, in that context, anomaly detections is happening in place, but it's more important to be fair. So you'll be seeing in a lot of cases where the AI models are not being fair, the ethics-based AI model, where the credit card nomination algorithms are failing certain customers because they belong to a certain racial category or income, in terms of base of a certain group of people, or in terms of profiles, in terms of recruitment, or in terms of spotting a certain criminal uh, kind of data is more infringing in terms of using a personal information. So a lot of things in terms of healthcare especially, it's a rule that a lot of data has been trained on, say, a white population, and the black population is highly underrepresented. Say for example, a certain type of a dressing sense or a certain type of a data set. Not necessarily all data are supposed to be anomalous in nature. It's important to understand the context. So that's why we can see one of the latest research of the Carnegie Mellon University is called fairness aware outlier detection. This fairness aware outlier detection is trying to say, is there a parity? Is it because of a group, a person, particular data uh, being represented from a certain group? Is it because of a membership in a certain group, something is an outlier? Or is it because of the data itself, something is basically an outlier? It's a very nice paper. I urge the audience to go through it. It's very important to understand whether my outlier detection is fair in terms of trying to determine whether, irrespective of the group membership of a certain data point, a particular thing is going to be a detection of outlier. That's why you do a little bit of shuffling in the whole process. So a fairness outlier detection is also an kind of open source database which is available. You can go through that in terms of the base framework. The fairness aware loss function, in the sense that whether it is belonging to a group A or a group B or a group C, the loss function is going to be very, very, very clear. So is it that formula which is coming clearly, or is based on a certain type of a group or anything? Is it being done in a certain manner? Is something that we want to look into before doing that. So it's also important to protect certain attributes. So when we're developing an outlier detection model, I think, is it a race, gender, income group, and in a certain group of access, is it going to be critical, not critical? So an outlier detection model should not be isolating a certain space of people, which is going to give a larger type of an impact. So sort of a balance is going to be required. So that's going to be critical. So if you look at IEEE research, a lot of issues are happening with respect to an AI model in terms of an embedded bias. So when we are training AI supervised machine learning models with a type of a data set, there is a bias already embedded into the system. When I already have embedded the bias into the system, my machine learning predictions always going to be in a certain manner. So how do we detect it? There are these AI and control framework. There is an explainable AI methodology. There is an overall in terms of a line method, or a global surrogate method, which try sharply values, which will probably try to tell you, is there a bias embedded in the system? While there is going to be a trade-off between model accuracy model explainability, and embedded bias. The whole idea of artificial intelligence proliferation is to ensure that we are going to manufacture human intelligence to have better proliferation of growth and prosperity. At the same time, it shouldn't divide, it shouldn't make the ethics issue much more probable. So it's important to have an explainable AI system where the anomalies in the supervised, unsupervised machine learning models are clearly identified. And the very critical thing in terms of the concept of explainability. World over, we're having regulations coming into place. Models have to be explainable. If it's a black box model or a white box model or glass box model has been put in, it has to be explainable. We need to be able to understand why a model is choosing the way it is choosing right now. If you see this age of the whole aspect of automation, industrial automation, if you're going to make the model to do by itself, it's going to have a lot of ramification. I would like to take the opportunity to take you through a very interesting website I came through recently in terms of this particular methodology is going to tell you why a particular AI algorithm is choosing what it's choosing. The whole aspect of explainability is very nicely explained in this kind of website I want to take you through right now. Heat mapping, sorry. Yeah. So so this is a website which talks about this is the picture given here. Say for example, here is this particular picture here. So you want to ask this question, there's an AI algorithm which is going to be a GPT-3 or an algorithm to say, is this a cat? Okay. The answer to the AI is given no, and the characteristics which the algorithm is using is this particular thing. So these are the most important characteristics with which the model is trying to predict a certain aspect. So is this a lion? It's also no. So how interestingly, if you see this one, I would like to take an particular thing. So are they playing tennis? See, if you see, this AI algorithm is saying they are playing tennis. It says 70% yes. It's because of these particular characteristics. So it's very important that while an AI algorithm is going to learn from supervise the number of data set it's trying to do, it can also be grossly wrong in trying to predict what it's trying to do. So this is where you need to go back to your before putting into production or trying to see what are the type of algorithms or anomalies trying to represent. It's important to see why these algorithms are doing what it's trying to do. So it's important to go through them and see. So it's a very good website. It's a very good thing to be created. It is called explainable AI, which can be interpreted. It can be seeing why certain things. Say for example, this is this uh, a dog. It's not a dog because of certain type of characteristics. So it is trying to say why it is choosing the way it is choosing. So we can go and see this heat mapping org. Yeah. Say for example, I want to do an image classification here. So I want to see why this image is what is this image. So it is saying that because of these characteristics here, which is want to say it is it is trying to predict. So it's very important to go through and see exactly what is the basis on which the AI algorithm and what are the rules on which what are the construct on which they are trying to do. Physical text classification, say for example. I want to load a random document. I want to see what is this trying to tell me. So it is trying to tell me the major themes of this particular document is basically saying it's a computers, its operating system is Windows miscellaneous. So so these are the basis on which there is a global explainability in terms of when I'm developing an algorithm. It's important to see how on a global basis, which is trying to make the local explainability is there. The local explainability comes into place where we're going to talk about a certain basis on which why an algorithm is choosing what it's choosing. So it'll be critical for us to understand why it is doing it so that certain anomalies, as we saw in the algorithm, uh, can be taken out from the process. So another thing is going to be handwriting classification. Is saying, say for example, I want to do this, I want to write this. So let's see what it gives. So it gives you classified as three, but this is not three. This is not three. This looks like three, for example, but if I'm going to do this, so the what I want to say in this point of view is that even though this is not a particular word, it's not a particular a number, because of the fact that the AI algorithm has to give an output, it is classified as five. So this is where you have to go back and say how we need to fine tune the model AI algorithm to say that not every result are accurate. See, if you're going to take a business decision based on it, it's going to have a lot of impact in terms of business results and so on and so forth. So the other topic I wanted to talk about is the GPT-3. So GPT-3 is definitely one of the the modern techniques, the modern technique which can generate a lot of things, a lot of use cases. It can give you, can summarize, can be one of the latest revolution. But what we observe is that the GPT-3 is highly toxic because it is learned from the internet of data, internet of aspect. What has actually happened in this particular case? It has learned those toxic elements, learned the not truthful element. So what they did by knowing this, the fairness outlier was detected. They went about and constructed something called the instruct GPT. So instruct GPT is primarily trying to tell you and learn from the toxicity. What it says that you know while the GPT-3 has learned from wide variety of dimensions, all of that, to make it more truthful and less toxic, the unique characteristics, the unique technique were there. They had come out with the model for Instruct GPT. So Instruct GPT per se, you can go through the paper, is very very clearly explaining. It is taking out the unfairness out of the whole model. If you're going to allow an unfair model to be in the mainframe, it's going to take over and make business decisions and do all of these things. It's going to create a lot of harm to society. So Instruct GPT is the way towards eliminating the anomalous pattern in the GPT, which creates a much more truthful or more less toxic model in terms of the usefulness of the AI models. So what I would want to do now is to shift gears and say, with the pandemic coming into place, there has been a lot of transformation in terms of digital usage, the cloud-based adoption. If you look at the Azure of the world, the AWS of the Google of the world, and the other players have gone into a lot of other things. So what is very useful? I want to take you a live example of an industrial IoT system where I'm going to monitor, say, a windmill, or I'm going to monitor the health of a certain type of individual. So I have a lot of these IoT systems, IoT devices, and edge devices, which is going to be transmitting a lot of information. I also have a lot of information, say from the ERP systems, the financial information is coming up. So Azure cloud services have got an ability to ensure that there is a methodology of getting the streaming data from the IoT hubs and the event hubs in terms of any type of applications, and everything can be on combined to the stream analytics. The stream analytics is a way in which the unstructured and structured information gets captured into a data lake. The data lake infrastructure is very interesting because if you look at data warehousing capabilities, it has be structured data. A data lake can be, I can have unstructured, structured, semi-structured. I can have, video, audio information. Everything gets linked into a certain other things. So what then happens is that there are two type of analytics coming here. One type of analytics is called as hot path analytics, where it is happening at the stream. Every minute you need to understand whether it is a certain point anomalous otherwise, or in terms of batch analytics. So these type of cloud-based systems are heavily useful for me to monitor certain industrial platform which is running in a certain type of a faraway location, or I want to monitor a turbine which is there in a different location, or I want to track certain health aspects. So one of the things which happened recently, we were in UAE in Abu Dhabi, where we were trying to have a Special Olympics. We probably launched this Special Olympics are for the participants of special needs with special characteristics. So they were all having a kind of a band within themselves. So this band was connected to an IoT hub, event hub, which was trying to monitor the abnormal patterns. So using these methodologies and having an anomaly detector enabled into this, we'll try to flag if some athletes who are specially enabled or going beyond a certain geographical boundary, or their temperature, pressure, or their frequency is getting a little bit more. This can have a lot of human values, human effects, which is coming into this place. There are three types of things which you can do, which you can automatically store the data, the batch, the amount of data for further analysis for batch. The second type of analysis is, say, the Power BI connection can be there, where it can be streamed. The individual aspect can be streamed as we speak. And the third bit of a use case could be that it can trigger further actions. Say, we will come into, we can probably raise a service ticket. It could be an email to a party. It could be a SMS alert. So the whole cloud-based orchestration can be heavily useful as we go along. I would like to take you through the Azure Data Factory. So Azure Data Factory is basically an orchestration platform wherein the data sources from on-prem, from cloud, from SaaS-oriented data sources can be ingested using pre-built connectors. These pre-built connectors, I can ingest data. It could be a weekly data, monthly data. It could be an online data set, or it could be a cloud-based infrastructure. So these Azure Data Factory infrastructures have got an ability to ingest data from various type of data sources, and this is where it's very, very, very interesting. So Azure gives certain time series based anomaly detection or cognitive based anomaly detection. So this is where it gives you a certain type of choice wherein you can bring your own models as we speak. You can bring your own models, so you can bring utilize the services, and the whole orchestration happens using the cloud-based infrastructure. So you don't need to have any kind of infrastructure. You don't need to have any kind of server base. So Azure Synapse Pool Analytics is also very critical in terms of I can store the database, I can orchestrate the whole process. Whether I'm a data engineer, I'm a data scientist, if I can use it for the Power BI, overall Power BI at aspect integrations were useful. So it is these services comes at a very reasonable price. It's also going to be very useful. So last but not the least, what I would like to conclude by saying is that while the AI adoption is going to be very critical, where the the AI adoption for organization is going to it's a long journey. Utilizing use cases of anomaly detection, unsupervised machine learning can show the management quick results. And in my opinion, compared to a supervised machine learning model where the level of interest in the infrastructure, the training, in terms of labeling of data set, the process is much more cumbersome. The anomaly detection can be a very good use case to start with for organization. So they can see whether financial data is showing me certain errors. I can fix it certain things. So I can tangibly look at whether what sort of a results AI models and algorithms showing me in a certain place. So it's also easy to use. So you have a lot of these uh, cognitive models can be used in AWS and Azure. There's so much of models to open source, they're lightweight in a certain other ways. So you can either use cognitive, or you're bringing your own machine learning models, which can have a lot of impact in organization, which can accelerate the transformation journey with respect to AI adoption in organization. Secondly, you can also have the AI based anomaly detection. It could be real time, it could be hot path, it could be batch anomaly detection. Say for example, you want to say in terms of anomaly attendance records, in terms of internet log data can be real time. A batch processing could be a financial information, it could be so many other information. So this way the organization can see a lot of value, which can be very clear value, can be much more quick win, if you can probably say, in the terms of an organization is concerned. So this is where it can enhance the whole process. Unsupervised machine learning comes very handy in this particular case. There are two types of anomalies, as I said. One is a temporary, one is the persistent anomalies. So persistent anomalies are really of matter of interest. So while the spikes and the dips are very important, just univariate, multivariate, a persistent anomaly, if identified by organization, it could be a VMware which is not being showing the right way. It could be health aspect. It could be a financial parameter. It could be a payment parameter. Something creeping or tending towards an anomaly is very important for organizations. So it can have a predictive element which can save a lot of things for the organization and make sure they can take timely corrective action before it's too late. And the last but not the least, if you look at all of these cloud-based anomaly detection methods, gives you a trigger-based approach. It could be reacting, responding at the right time. It could be real-time adoption rather than becoming it's too late. It could be a trigger, an SMS. It could be an alert, and the whole aspect of a real-time visualization can be very key in this whole type of adoption. So with this, I would like to with this I'd like to conclude my overall presentation, and looking forward for any queries or questions as the case may be. Thank you.
All right. So thanks very much, Sudharshana, for those insights on anomaly detection. One interesting statement that you made there, this can be an area where an organization can start their AI adoption to win that confidence and impress upon the decision makers or the board members. But one question I have, because when I was reading about anomaly detection, the most annoying factor about that is the false positives, where they end up acting on it, and they may annoy the customer, and they may go and disturb some customer who is loyal to you and all. So won't that be a dampener when it comes to going back to your decision maker, saying that yes, AI can help us, AI can help us in this way, but it can become a dampener in a real situation? How is that handled, Sudarshan?
See, if you look at the AI adoption in organizations, it's a lot to do with the culture of the organization. How are you going to adopt? How to change my methodology? It's not going to be a magic dust you're going to put into the whole scheme of things. If you look at a lot of the research which says not a lot of pilot projects are seeing its daylight, it's primarily because it's a very complicated thing. A lot of changes are happening as this false positive, false negative. It's not something which is true. In my experience, which I try to do a lot of super machine learning models, see, anomaly detection can show you quicker results. It can give you a very clear indication about what is going right, what is going wrong, with little bit of a lesser type of an infrastructure cost, the availability and all of these things. As we said in the presentation, the human in the loop is critical. You're going to allow the machine learning models to operate, embed, and take business decisions. That is where the organizations go wrong. So where I believe that using unsupervised machine learning, anomaly detection as a start to show the value organization, where you're going to show to your senior management or executive team is saying you're going to see that the value is coming out. However, the cultural change is going to be critical. There's going to be some investment happening. There's going to be some failures which is coming in. False positive is an inherent risk, but what do we do to mitigate it? Do we evaluate the model? Do we understand the model drift? Do we constantly see, is there a human in the loop where the confidence interval is not reasonably there? If we're going to uh, reject a customer, maybe that is where we're going to have a much more stringent processes. So risk evaluation is going to be critical, and with that, I think it's a very kind of very good science to adopt. And data science is not only for the data scientists. It's going to be understood by everybody in the organization. Constant adoption of data, constant kind of accumulation of data is critical. Constant evaluation, what are the catalog of these models going to give you, is going to be critical. Entity wise adoption is going to be important for you to democratize AI within the organization, I believe.
No, absolutely, you said it. So yeah, adoption is not just bringing some software and setting it up. It really needs the whole organization setup to be changed for the AI adoption, from the decentralizing the decision making up to believing what the AI has given you, and as you said, the human in loop factor is one of the most important factor when it comes to final decision making. So that's great insight. Now I have in the audience, there are more number of students who are doing their management studies in analytics and data science. So I'm sure they would be excited to look at this new career track. We always keep telling our members and students that there are more than 300 to 350 career tracks in AI analytics and data science, and I'm sure they are seeing multiple of those in anomaly detection area. So what would be your suggestion to them for them to where to start if at all they are planning to pursue their career in anomaly detection, and what all it has in its path towards success?
I think, in my experience, while supervised machine learning is a king of models, I think unsupervised machine learning algorithm detection has got a lot of future in its place. So first and foremost, I think it's got a lot of statistical relevance. I think these various libraries, as I said, PYOD, PyGod, TensorFlows, these are very good open source material resources which is already available. Second is the utilization of cloud-based services. If you look at Azure, AWS, they've got a lot of these anomaly detection services getting offered. So how that is going to be getting integrated with the cloud-based orchestration. So you're going to specialize in a certain way. Very importantly, I'm from the audit profession. I firmly believe that the risk and the audit space have not embraced unsupervised machine learning or AI in general. While it's there in banking and insurance and all of these cases, there's a fair amount of financial data. We have healthcare. So we're going to focus on a certain element of aspects. Go to then zero in on certain use cases. Start doing the live use cases. Try to understand, because these from a textbook to an actual live scenario is going to be completely different. So cloud is integral, because future is going to be the cloud and how we're going to integrate. Important to understand infrastructure. It could be Azure, Google, or AWS. It's going to be critical, and understand the clear libraries. PyOD has got so much of library, supervised, unsupervised, and the graph-based outlier detection is also coming into vogue. So those are there. If you see in the US, there are a lot of conferences happening in outlier detection, the ODD conferences organized by Carnegie Mellon, MIT. But however, in India, I don't see a lot of adoption, a lot of conferences focus on outlier detection, anomaly detection. I think there's also an opportunity to host conferences and make sure that. And the third and the most important thing is going to be explainable AI. While the AI is going to become more and more into the common living aspects of business, is it explainable? Is it ethical? It is biased. There are a lot of anomalies existing within the algorithm, which is a huge area by itself. The students and professionals can leverage upon.
Absolutely, absolutely. Thank you very much, Sudharshana, for taking time on a Sunday morning and coming on our platform. It's surely a great to have you here. But surely this is a subject 40 minutes doesn't do justice to it. I'm sure about it. And you had great presentations, especially the demos were very interesting, and some of the websites that you mentioned will be surely useful. But we surely will look forward for more sessions around little more in-depth aspects of anomaly detection. So I'm sure that will be something that me and our members will be looking forward to. Thank you once again for taking time and coming on this platform.
Definitely. Thank you so much, NK. Thank you so much for the whole team of 3AI.
Thank you. Thank you for every participants. Thanks for joining, and see you again next Sunday on the edition 93. Thank you very much. Bye-bye.